That's just where that was supposed to go.
Hi, welcome back. Today I'm back on the Byzantine Sundial Calendar, and I'm going to make the lunar display, or at least part of it today. I'm going to cut the wheels for it. There's two wheels involved in the lunar display because it shows the lunar node and the position of the moon within the zodiac. So I'm going to cut these two wheels. They're slightly different to the other wheels because the other wheels are all just flat. These ones are actually have got a little bit of a relief. This one's got a relief so that it can fit within the train, and the other one has actually got a feature machined on it so that it can fit as a bearing within the lunar node disc. So I'll just zoom you in on the drawings and you can see what I mean. So as you can see here, the lunar display wheel is here, and it has to clear the wheel I call F, wheel F, has to have a little bit of clearance just here. Hence this wheel has got a machined recess on the other side of it. The other wheel is being driven by F and is underneath here, and that's got the bearing surface that sits inside the display disc. So the wheels I'm going to be cutting today are G and G1. So it will be 39 teeth for G and 36 teeth for G1, and these are my outside diameters that I've worked out using the 80-degree tooth form the same cutter that we've used for all the other wheels. These are the two wheels I'm making today. This is the little relief that needs to be on this one, which is going to be 0.25, and I've increased the dimension slightly to 2.25 for the actual wheel, so that the wheel will be 2.5 thickness in total to match in with all the other wheels that I'm doing. And then on this one, this is the relief that's going to be the feature that's like a bearing surface, and that means that we need an overall thickness of 4.5. And again, I've increased the wheel thickness to match in with the others, which gives us a 2mm bearing surface and a 2.5mm thickness of the wheel. So I need some 4.5mm brass and some 2.5mm brass.
Okay, so we're getting started with rummaging through the drawer, see what stock we've got in. Got a piece here which is an appropriate thickness to get the 4.5mm overall thickness of the wheel. First job will be to mark out the rough overall diameter of the wheel so that we can cut a blank from this material. I tend to try and use the material as sparingly as possible, so here you can see me sort of trying to fit my blank on the edge of the brass plate so that I can get as much out of it as possible. Over to the bandsaw, and then tidying up the flashing, taking the burr off so we've got a flat surface on the back of the blank. This is an aluminium chuck in the lathe. I'm just giving it a light facing cut. I use these a lot for superglue fixturing. So in this case, we're going to face off, and then we're going to superglue the blank, holding it in place with the tailstock. in the tailstock is a centre, which I'm picking up the centre divot that I made earlier, which then roughly centres it onto the fixture with the super glue gripping. Leave that to set up for a few minutes, and then we can start bringing the OD down. Initially we've got quite an interrupted cut because of the rough sawn surface on the edge of the blank. So the first thing is to get through that and then bring it down to a diameter. This will not be the finished diameter at this stage. It'll just be a trued diameter to be able to put in the 6 jaw. And we'll take a facing cut so that we're making the face of the blank square to the outside diameter. The first feature that I'm machining into the blank is the boss that's going to be the press fit into another component. It's going to be the press fit into the node display disc. Because I don't want to turn over the top of the teeth after they've been cut, because this will introduce a burr over every one of the teeth, I'm bringing down the thickness of the teeth, the area that will become the teeth, first, as part of the blanking process. And also, because of how I'm going to be fixturing it to cut the teeth, I wanted to put the boss section on first as well. So that's what's going on here. Bringing the boss in and facing off the finished thickness for the area that will become the teeth. And the final face-off to bring the overall thickness to dimension. So just kissing the burrs off the edges with a file, and that's the blank made. So as I said earlier, we wanted the outside diameter to be oversized, but to be concentric to the other features that we turned, i.e. the boss feature. So now we can go into the 6-jaw chuck. This means that we can center drill. Following up with a 3.8mm drill to through drill the center hole. And then following that with a 4mm reamer. Nice and slow, plenty of oil. And we should be left with a nice concentric 4mm bore, ready for fixturing, for cutting the teeth. So we'll just knock the burrs off. I actually use a jeweler's burr in a pin vise, just by hand. And here's the fixture. I've got a number of these that I've made for different jobs over the years, but this one I actually made recently. It's got an accurate 4mm turned section. So we get a nice concentric fit, and then there's a washer that holds everything up, and then a nut. And that will just be pinched down. We don't want the blank to move, but we don't want to absolutely rock down on everything. So I will just nip it up with a spanner. Now we can turn the outside diameter, because we're now turning this concentrically to the center bore that we've made. So any errors there may have been with swapping between 6-jaw chuck and the super glue chuck, that will be taken out now by bringing the outside diameter down. As it happens, because I'm using Swiss machinery, it tends to be that there's very little run out induced anyway, but it's just good practice to do it in this order. That way you're pretty much guaranteeing concentricity of the teeth. So just knocking the burr off again before we start cutting the teeth. When setting up for wheel cutting, it's always useful to be able to see the land that you're left with, so just use Sharpie marker to make that land more visible when setting up. You've seen me using this setup a number of times. This is my Shawblin 102 with vertical slide set up for wheel cutting, and that's got the Shawblin dividing head attachment fitted. So I tend to just do a few small cuts, as you saw me doing there, to bring it on to something near, and then I'll do a couple of teeth where I'm sort of tuning it in, making adjustments as I go. And then once I've got it dialed in so that I'm happy with the land that's being left on the tooth, I'll lock everything down and cut the teeth. That's the vertical slide being locked. Onto the next tooth. Set the sector and off we go. So one cut and one division. Okay, so with the teeth cut, we can take the wheel off the holder. That's just where that was supposed to go. And you can see the triangular tooth form there. One wheel. This part I'm making now is the lunar node display disc. I'm making it in much the same way as a wheel blank that you've seen me making earlier, using a super glue chuck to support the turning work. Bringing down the outside diameter first, before turning the various features, including the board hole and the internal turning. The internal turning is going to become a bearing surface for the inner display disc, and it's also going to have the press fit diameter to interact with the wheel that we made earlier in the episode.
I've just gone back and watched Clickspring's videos of making the Byzantine Sundial Calendar, and when he's making these parts, he makes them in a completely different way to what I've gone and done, and I quite like the way he did it because he maintains concentricity all the way through, but he's doing it to get really good concentric results out of a sort of three-jaw chuck type setup of a machine. I've got the luxurious setup of having a Shorblin with six-jaw chuck and things, so I've done it in a little bit of a different way, but I'm happy that these things are going to be perfectly concentric. So that will press fit onto there, and then but before I'm going to do that, I'm actually going to hold this in a collet on here, and I'm going to bore this diameter here, then finish the back side of this, and then this will press fit together, and then there'll be a final facing cut inside to finish the job off, and then that will be that component. There's another one of these which goes on the other side, which is probably going to be my next job, to sort of get that to the same state as this with the rough components, and then finish the two together.
Okay, so that wraps up this video. We've made several components. So we've made the two wheels. This is one of them, which will press fit into the lunar node display. There's the other one for the other side, for the solar side here. These will be bored through later. We've also made the wheels that drive the display disc that is sort of mounted on top of these wheels. There's the one for each side there for the solar and lunar sides. And this is the node display for the lunar side. There will be another one of these, a little bit different, but a similar component later on. Thank you very much, and I'll see you on the next video.